Singapore is a small country with a very big problem. It runs out of space. Yet it sits at one of the most important shipping crossroads on Earth, where global trade passes like a river of steel and fuel. Every container you see here is time, money, and momentum. And for decades, Singapore's port machine has been running at full speed. But the old way of doing it created a new kind of limit: fragmentation. Terminals spread out, operations split across different coastlines, trucks and transfers moving through a crowded city. If the port is the engine of the country, then land is the fuel, and the fuel was running low. So Singapore made a decision that sounds impossible. If there isn't enough land for the world's busiest logistics work, then you build new land. Not a small extension, but an entirely new megaport district designed to swallow the next generation of global shipping. This is Tuas Port, a project built in phases, built on reclaimed ground, built to operate like a machine. And the first step is not cranes, not roads, not buildings. The first step is the sea. Because you cannot place a megaport on open water unless you can reshape the ocean floor. Dredgers arrive like floating factories, and they begin harvesting the seabed. Sand and slurry are pumped through long pipelines, spreading outward like liquid terrain. The coastline moves, the water retreats, and new ground appears where there was none. But reclaimed land is not land yet, not in an engineering sense. It's wet, soft, unstable, a surface that can swallow heavy equipment if you rush it. So the next battle is against settlement. Soil improvement rigs work in grids, pushing energy into the ground, densifying layers, forcing the future to become solid. This is how you turn a temporary surface into something that can hold cranes, roads, and the weight of global trade. And once the ground can stand, the edge of the port must face the sea. A port needs a seawall and a quay line, a hard boundary where ships can dock and cranes can work. But building a long seawall in the ocean is not like building a wall on land. The sea doesn't give you a foundation. You have to bring one with you.
Done too.
That's where the giant caissons enter the story. These are not small blocks. They are massive hollow concrete structures, built like 10-story buildings, designed to become the skin of the coastline. In fabrication yards, the scale becomes surreal. Rebar cages grow like steel forests. Concrete pumps pour non-stop into forms that look like the walls of a fortress. Workers become tiny figures inside structures that feel more like high-rises than construction elements. Every corner must be precise because when you place these in the sea, you don't get unlimited second chances. When a caisson is ready, it becomes a floating giant. It's moved out, guided, towed, and aligned with slow, careful control. Tugboats pull, cables tighten. The element glides across water like a drifting building. Underneath, the seabed must be prepared to accept the weight. Rock mattresses and engineered layers form a stable bed, resisting currents and erosion. Then the caisson lowers slowly into position. Water surges around it, swirling and foaming as it settles. And when it seats correctly, the coastline gains a new piece of armor. Repeat this again and again and again, until a seawall becomes a line, and the line becomes a new shore. This is how you build land with a ruler. Once the boundary exists, the port begins to fill in behind it. Stronger ground, paved yards, internal roads, drainage, utilities. Because a container port is not just a waterfront, it's a city of machines. Pavement and markings create the grid that everything else will follow. Power and data lines run under the surface because the future port is digital by design. Lighting masts rise like watchtowers, turning night into day, and then the cranes arrive. Ship-to-shore cranes assemble on the quay, towering structures that can reach across massive vessels. Each crane is a moving bridge, a steel creature built to lift containers at industrial speed. Alongside them, the yard cranes appear. And here, the story shifts from pure construction to pure choreography. Because Tuas is not designed as a traditional port where fleets of diesel trucks swarm everywhere. It's designed to be automated, intelligent, and scalable. In the container yard, automated cranes stack with clean precision. And between yard and quay, automated guided vehicles glide in controlled lanes. No driver cabins, no chaos, just a flow system.
Watch the roller.
Containers move like parts on a factory conveyor, except the factory is kilometers wide. And to make that flow work, you need something even more important than cranes. Control. Operations shift into remote control centers, where operators watch the port like air traffic controllers. Cameras, sensors, and planning systems turn the yard into a live map of moving steel. A crane movement here changes a vehicle route there. Everything connected. And that connectivity needs a network built for machines. Low latency, high reliability, always on. Because when automation scales up, a dropped signal is not an inconvenience, it's a stoppage. So the port becomes a digital ecosystem. Cranes, vehicles, and yard systems all coordinated like a single organism. But a megaport built for the future still has to survive the present. Salt air, heat, rain, corrosion, mechanical wear. Maintenance bases and inspection regimes become part of daily life. Bolts are torqued, rails are checked, sensors are calibrated. And while the machines move containers, the human role shifts, from driving to supervising, from hauling to controlling, from muscle to precision. Then comes the moment when construction turns into reality. A ship arrives at berth, and the cranes begin their dance. The hull towers overhead, mooring lines pull tight, spreader locks onto steel, lift, transfer, place. Yard cranes stack, AGVs glide, the grid stays clean. This is the port as a machine. A mega system designed to reduce wasted motion. And because the world is changing, the port's power system changes too. Electrified equipment replaces old assumptions about fuel and exhaust. Charging bays replace refueling queues. Quiet movement replaces constant engine noise. The result is a port that doesn't just grow, it evolves. And it does it in phases, because you don't pause global trade to build the future. One side operates while another side expands. New seawalls extend, new yards harden, new berths appear. The coastline becomes a project timeline you can see from the air. What makes Tuas truly impossible isn't only its size. It's the fact that it is designed to consolidate and streamline a nation's port activity into one coordinated mega hub. It's built to handle the biggest ships, the densest stacking, and the fastest turnaround, without turning the city into a traffic jam of containers. And the payoff is simple.
Is this container sealed? Let me see the manifest.
A port that can keep Singapore competitive in a world where supply chains punish delays. A port that can scale into the 2040s without constantly reinventing itself. A port that treats land like the rare resource it is, and uses automation to multiply what that land can do. In the end, Tuas Port is not just construction, it's geography rewritten. It's a new shoreline drawn by engineering. It's a factory for global trade built on ground that used to be sea.
Confirmed, 45 Newton meters.
And when you pull back far enough, you realize the true scale of the ambition. This is a project that turns national survival into infrastructure. Because in Singapore, space is not something you find. It's something you build. And in Tuas, the country is building a port that isn't just bigger, it's smarter. A port that moves like software, but hits like heavy steel. A place where machines do the hauling and humans do the thinking. A coastline that holds the weight of ships, cranes, and an entire economy. A new edge of land where the future arrives in containers.
Schedule aligns with the arrival of that vessel.
I've updated the timeline on the tablet.
And every day it runs, it proves the same idea. If you can't expand outward, you expand into the ocean. If you can't add land, you manufacture it. If you can't afford wasted motion, you automate it away. That is Tuas Port, not just a mega project, but a mega machine, built on reclaimed ground, built to move the world.